Okay, class, this is the continuation of 9-1 Intro to Limits. When we started this, we showed pictures, so we showed how with pictures you did the problems. We showed just general equations, how you did it. And the third one here that we're doing, it's basically a piecewise, if you've ever seen them. And what a piecewise equation does is it gives you different equations that you would get a picture like you did at the very beginning when we did the pictures. But they don't show you the picture, they give you the equations. The minimum number of pieces that you can have is 2 pieces, which is what I have here. So I have evaluate f of x, the general function, stating that it's x squared plus 1 if x is less than 2, and it's x minus 1 if x is greater than 2. And I just chose 2 as a number. Whatever number is chosen for x, though, has to be the same in both. So in one case, you wouldn't have x less than 2, and the other x greater than 3. So those numbers will be the same, and the limits will approach that given number. You will see below it the 4 questions are the same 4 that we always have. The limit as x approaches 2 from the negative side of the function, as it approaches from the positive side. The limit as x approaches the number, and f of the number. What you have to do on this one is pick the correct piece. So for the first one, since it says x approaches 2 from the negative side, you want to pick the piece where x is less than 2, which in this case is the top piece. So I wrote the x squared plus 1. As we did before, I put the 2 in for the x, so 2 squared is 4 plus 1, the answer is 5. For the second piece, when I approach 2 from the positive side, since that means the greater side, I use the x minus 1. I put the 2 in, 2 minus 1 is 1. When you get to the third piece, in the past, as we said, if the 2 exists, it's what it is. On this one, the limit as x approaches 2, it's going to be the same thing. Since those 2 numbers were not the same, it does not exist. For the fourth question, it said f of 2. So we want to know what it is when x is equal to 2. When we go back and look at the original problem, neither one of those had an equal to sign. So we say that it was undefined. In other words, they did not tell us what to do with it. Now, if you look at the bottom one, I took the exact same function except for I chose and I made the first piece less than or equal to. So you can see that the answer, the limit as x approached 2 from the negative, is the same as it was above, it was 5. The limit as x approached 2 from the positive side is the same as it was above, which is 1. The limit as x approached 2, again, does not exist because the first 2 answers were not the same. But on the bottom one, you chose the part that had the equal. In this case, it was the x squared plus 1, so I put the 2 in. 2 squared plus 1 gave me the 5. So that's basically the difference there. The last question on both is f of x continuous at x equal to 2? In both cases, they're no. And the generic reason is because since all 4 answers were not the same, then it's not continuous. There were gaps in it, is basically what happened. On the notes that I attached, I then did another find the limit of a rational. In this case, when you look at it, you will see that the numerator and denominator, if you just plug the numbers in, went to zeros. And a lot of people would stop there, but what we learn is you have to go back and see if it will factor. And the numerator factored on that one. So you factor and then you proceed with the limit, and that's shown on page 6. On page 7, I did a couple other limits of rationals, but these were ones that did not factor, but when you put the numbers in, you got answers. If you have any questions, always feel free to contact me. The last part, and again, I'm having trouble here with my overhead lights, okay, is the difference quotient. And I often debate on doing the difference quotient, but since we are going to be going to derivatives, we need to know how to do this. Most textbooks give the difference quotient as it is there on the top. The limit as h approaches 0 of f of a plus h minus f of a all over h. What I did on this board, and it's not like this on the paper, is I tried to show you that it didn't matter whether you had a or x or any other variable. It would be the variable that was in your equation. The h has to be there. But what I did is I took the 4 steps. The first is you just put a plus h in for the original variable that was there. The second, you subtract the original function. The third, you take that answer, divide it by h. And the fourth is you take the limit. So there's an example here, and I said if f of x is equal to 3x minus 5, because I usually use x's in my equations. So I did the first step. I replaced every x with x plus h. So I took 3 times x plus h minus 5. Gave me 3x plus 3h minus 5. For the second step, I took that step and I subtracted the original function. So I did 3x plus 3h minus 5, and I subtracted the original function of 3x minus 5. And you will note that I put it in parentheses, and I always have students who say, I don't need to put it in parentheses, but then they forget to distribute, so they end up with wrong answers. So that gave me 3x plus 3h minus 5 minus 3x plus 5. This step, when you combine your like terms, your final terms that are left must all have letter h's in them. They could have h, they could have h squared, they could have xh, but they have to have a letter h. If you get to this step and you have a term that has just x's or just numbers, you've made a mistake. And it's likely that you forgot to distribute the negative before subtracting the whole function. Step 3 is you take the previous step, which is the 3h, and you divide it by h. That just gave me 3. And the last step is you take the limit of that. So the limit is x approach 0, 3, and you go back to your limit rules. And the limit of a constant is a constant, so the answer is just 3. As I said before, some of you may have learned this before where you did it all as one, and that's fine. I'm just trying to show people who maybe have never seen it before that you can do it in steps, and later on it will be called the 4-step process, and this is why. Again, if you have any questions, please feel free to contact me.